I have two circuits. This one is series circuit. What makes it a series circuit? Current has only one pair. And I have a parallel circuit. What makes it a parallel circuit? Current has multiple paths. Okay, so here we're going to solve the problem using the equations we derived earlier. Okay, so I'm going to just write the three laws of voltage, current, and a resistance for the series circuit. So for the resistance, the equivalence resistance is R1 plus R2, and for the voltage is the voltage divided in the series circuit. So we're going to write voltage 1 plus voltage 2. The current is same across the circuit, so basically we're going to have the same current across the circuit. So let's write the laws for the parallel circuit. So resistor to the voltage, and voltage same across the circuit. Let's do it for current divided, so current share, and the resistance, and the more resistor you add, the less resistance you have. And I have 6 ohms involved too, 10 ohms. Okay. Now voltage. So this is the ohm. So I have 12, I have 10 ohms. EIR. So the current is, so voltage is 30, and resistance is 10. So the current is 3 amps. Okay. So I have 3 amps over here. So the current is same across the circuit. So here is I have 3 amps. Okay, 3 amps. Here is I have 3 amps, 3 amps. So total current is of course 3 amps. Now let's find the voltage. So how much voltage I have across this resistor IR? So the 3 times 4 is 12. So voltage is 12 volt. Okay. For valve 1, 12 volt. Okay. For valve 2 is 18 volt. Okay, so total voltage we have 30 volt. Okay, so this is for the series circuit. Now let's do the parallel circuit and let's see how that is different. This is same across the circuit, so the 24 volt and 24 volt. So that's easy. Okay, we took care of the voltage. Now let's take care of the current. Parallel circuit, share the current. Share the current. Okay, so what does that mean? Let's find, use the Ohm's law to find the current, VIR. So the total current would be, before we do that, let's find the equivalence resistance. So 1 over R is equal to 1 over 6 plus 1 over 8. The LCD of 6 and 8 is 24. So 1 over R is equal to 24. 6 goes to 24 4 times, 8 goes to 24 3 times. So you have 7R is equal to 24, 3.43 omega. Alright, so the current is the resistance, total resistance is, we know the total resistance 3.43. Okay, good. Now what we're going to find is, let's leave the equations here. 2. Okay, so the resistance right here is 6 and resistance right here is 8. So we have 6 plus 8 is 3.43. 6 plus 8 is 3.43 by Ohm's law. Okay. Now voltage is same across the circuit. So 24 is 24. Now we're gonna have to find the current. Current is shared. So keep that in mind. So let's find the total current. How much current flow in a clockwise direction? So what would be the total current? Total current would be V over R. So V is 24 and R is 3.43, and that would be 7. So total current is 7 amps. 7 amps flow from positive terminal to the negative terminal. But how much current here? Because it shared the current. Okay? This bulb would be brighter than this bulb. This bulb would be a little more brighter than this bulb. Okay, so let's find the current over here. So the current is V over R. So V is 24 and R is 6. So 4 amps. So current is 4 amps over here. Let's find the current over here. So I is V over R. So V is 24 and this is 8. So it's 3 amps. 3 amps. And this is called Kirchhoff current law. Kirchhoff current law tells us that the total current remains same. So the current 4 plus 3 is 7. So 4 amps plus 3 amps is equal to 7 amps, and this is called Kirchhoff's current law.